Here we're being given a vector field and asked to solve on a line segment from 2, 2 to 10, 10. Remembering our equation for line integrals of vector fields on the plane, we're going from A to B using the vector and dot product with r prime t dt. So the first thing we need to do is come up with our parametric equation for the line. One of the formulas to do that, let's use r is equal to 1 minus t, and we'll make the point a vector from the origin, 2, 2 plus t, and our second point. So now we'll plug this in. This becomes 2 minus 2t, 2 minus 2t plus 10t, 10t. Okay, now adding these two, we come up, we've got 2 plus 8t, 2 plus 8t. So that gives us our r vector. Now we also need to solve for r prime of t, and that's simply going to be 8, 8. And also keeping in mind that our t values are going from 0 to 1. It's just the one line segment that we've evaluated. Now plugging in our values into the f function, we can get started with going from 0 to 1. Now our numerator simply becomes, evaluated using that, 2 plus 8t, 2 plus 8t. This is now going to be over. We're taking the square of each of these, and it's raised to the 3/2. Okay, so with this we can, there's going to be, we're adding, x and y are the same, so we've got two values of, then 2 plus 8t for each of them. It's going to be squared, and then it's raised to the 3/2. Then we need to dot product with our r prime. And then this is dt. Okay, of course, before we take the integral, we'll go ahead and do our dot product. And with that, taking, well, both of them are the same, and that's going to multiply and then add. That's going to give us 1632. Well, let's go ahead and factor out the 2. There's going to be 2. They're both the same. 16 plus 64t. And then this is going to be over. We can go ahead and take out the, if we go ahead and take out the 2, and that's going to have to be to the 3/2, then that will leave us with, well, that's going to simplify, and this is going to come down to 2 plus 8t cubed, and this is going to be dt. Okay, so still have more simplifying. We can go ahead and, let's go ahead and bring some of this out front. This is going to be 2 over 2 to the 3/2 is going to be 2 root 2, and then those will cancel. Then in our integral, we're getting 16. Let's factor out the 16. That'll be 1 plus 4t. That's going to be over. Well, down here, we can factor out the 2. It's going to be 2 cubed. And down here we also have 1 plus 4t, and that's cubed. I'll take it this far. Copy this again. Again, this is 0 to 1. So down here now we've got, well, let's see. When we simplify out, this is 16, and this is 8. Well, that's just going to give us another numerator of 2. I'll put it out front. 2 over root 2, integral from 0 to 1. And now, well, these we can factor out. So it's going to be 1 over 1 plus 4t squared dt. So now we can do a u substitution in here. We'll use u is equal to 1 plus 4t, and then the du is equal to 4 dt. So 1/4 du is equal to dt. So next we put in our values of u, set up our integral using u. We have 1/4 du, so we'll go ahead and put the 1/4 out front. That simplifies to 1 over 2 root 2. Now our limits of integration, we put u is now equal to 1 plus 4t, so this now is going from 1 to 5. And plugging this in, we now have 1 over u squared. This is du. Okay, so now we can go ahead and take the integral of that. This is going to be 1 over 2 root 2. We now have negative 1 over u, evaluated from 1 to 5. Yeah, that's negative. Don't want to forget that. So this now comes in. We still have our 1 over 2 root 2. Plugging this in, we now have negative 1 over 5 minus a negative 1. So that's plus 1. This now becomes 4/5 in here, which would equal 4 over 2 root 2, 5. We can cancel that. Is equal to 2. Gives us our final answer of, well, let's see, and go ahead and move that up. Gives us root 2 over 5.